Hello again, and welcome to another session of our Learning Together tutorials sponsored by the Brosis Foundation. This is another math tutorial, and it's an extension of what we have been doing over the past weeks. On Tuesday, we studied how to factorize trinomials, quadratic trinomials, that start with, that have a lead coefficient that is not 1. And today we're going to go to another level. We also did some factoring by grouping last time we were together. Today I'm going to cover, I hope to cover two things. I hope to cover the quadratic formula as well as introducing you to factoring cubic expressions as well as solving cubic expressions. So here's what I would like to bring to your attention. If I ask you to solve, say for example, x squared minus 4x minus 12 equal to 0. If I ask you to solve that quadratic equation, it's quadratic because the highest exponent is 2. You might realize that I could solve this by first factorizing it and then afterwards using the zero product property. We realize that this could be factorized as x and x, and what two numbers multiply to give us negative 12 and add to give us negative 4. I think we could see negative 6 and positive 2. Let's check. Negative 6 times positive 2, negative 12. Negative 6 plus 2, negative 4. And then we have something times something equal to 0. And this is when we came up with the idea that this implies that x minus 6 equal to 0, or either this is equal to 0 or x plus 2 equal to 0. So we end up with two linear equations to solve this quadratic equation. In other words, x is equal to 6 or x is equal to negative 6. So those will be our two answers. So the reason that I'm going to be teaching the quadratic formula today is not every quadratic equation can be solved by factoring. There's some expressions that you just can't factorize. So you need to have other methods that can be used outside of factoring, because if you can't factorize, then you're going to be stuck. So that's where that takes us into the quadratic formula. Okay. The quadratic formula says any quadratic equation can be solved using the quadratic formula. There are no limitations. Anyone can be solved using the quadratic formula. What does it say? If you're given any quadratic equation, ax squared plus bx plus c equal to 0. Notice where a, b, and c are numbers. A, b, and c are numbers. This is your variable. Your x is your variable. And it's to the power 2, so that's what makes it quadratic. The quadratic formula says x will always be equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. That's the quadratic formula. It's taking the coefficients a, b, and c, plugging them into this formula, and these will give you the values for x. Okay? And this is called the quadratic formula. So this is what it is. And as you get into advanced math, you must know the quadratic formula. So what I'm going to do now is the example that we just did, that gave us the answers 6 and negative 2. Let's try solving that using the quadratic formula. So x squared minus 4x minus 12 equal to 0. That was the equation. So in this case, A is equal to, B is equal to, and C is equal to. A is a coefficient of x squared. In this case, it's 1. B is a coefficient of x. It's negative 4. C is the constant. It's negative 12. So we're going to plug in these three numbers, 1, negative 4, negative 12, into this formula and see what happens. So with this, we have x equal to, b is negative 4, so minus b is going to be 4, plus or minus the square root of b squared is negative 4 squared minus 4 times a. What is a? A is 1. And then c. What is c? Negative 12. And it's all of that over 2 times a. 2 times a, and a is 1. So what's that equal to? Well, it's 4 plus or minus the square root of negative 4 times negative 4 is 16. Negative 4 times 1, negative 4. Negative 4 times negative 12 is 48. All over 2. So 16 plus 48 is 64. So it's equal to 4 plus or minus the square root of 64 over 2. What is the square root of 64? Square root of 64 is 8. So it's going to be 4 plus or minus 8 over 2. Okay, so notice 4 plus 8 is 12. 12 divided by 2 is 6. 4 minus 8 is negative 4. Negative 4 divided by 2 is negative 2. And that's how we end up with our two answers. Same as before. So realize that if you know how to factorize, we did that in 2 steps. But just in case you can factorize, you have the quadratic formula and it will work. Okay? Let's try another one. Solve. I'll take one from my sheet here. Say 2x squared minus 3x minus 5 equal to 0. So 2x squared minus 3x minus 5 equal to 0. Again, I know that this can be factorized, but let's pretend that you can't factorize it. And let's use a quadratic formula. In this case, a is equal to 2, b is equal to negative 3, c is equal to negative 5. And I just need to plug those into the quadratic formula. X is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. So that's going to be equal to minus b is 3 plus or minus the square root of B squared is negative 3 times negative 3 is 9. Minus 4 times A times C. So it's 4 times 2 times negative 5. All over 2 times A. 2 times 2 is 4. So what's that equal to? Well, it's equal to 3 plus or minus the square root of negative 4 times 2 is negative 8. Negative 8 times negative 5 is 40. 40 plus 9 is 49. 2 times 2 is 4. So therefore, x is going to be equal to 3 plus or minus 7 over 4. Okay? So we know that x is equal to 3 plus 7 over 4, or x is equal to 3 minus 7 over 4. 3 plus 7 is 10. 10 over 4. And we simplify that to 5 over 2. That's it. 3 plus 7 is 10. 10 over 4 is 5 over 2. 3 minus 7 is negative 4 over 4 equal to negative 1. So our two answers are negative 1 and 5, positive 5 over 2. Okay? Now I guarantee you, if we were able to factorize that, we will get the same answer. If you factorize that, that's exactly what you'd end up with. This is actually 2x. Let's see, 2x. Okay, so we need, so let's check. 2x times x, 2x squared. 2x times 1 is positive 2x. Negative 5 times x, negative 5x. Negative 5x plus 2x, negative 3x. Negative 5 times positive 1, negative 5. And from this, put this equal to 0. Put this equal to 0. We end up with 2x minus 5 equal to 0. Therefore, 2x is equal to 5. Therefore, x is equal to 5 over 2. So this one, x plus 1 equal to 0. So x equal to negative 1. Look at it. Because you could factorize, look how easy this works out. If you couldn't factorize, quadratic formula, same answers. This is a long way home. This is a shortcut. So you see, there is value in being able to factorize. So what we need to do now, we need to do a question that cannot be factorized. Okay, so I'm going to just write a random question out of my head that I hope cannot be factorized. So let's go with okay. This one can be factorized. Let's use a different number. Let's use 5. Okay. So A is equal to 3, B is equal to R. put this as plus, so it's different, is equal to 2 and A, sorry, C is equal to -5. So these are our numbers. We already know the quadratic formula, so I'm not going to write it a third time. I'm going to use it, okay? So the formula says x is equal to minus b plus or minus the square root of, minus b plus or minus the square root of b squared minus 4 a c. All over 2 times 3, which is 6. 2 times a, which is 6. So that's equal to -2 plus or minus the square root of 2 squared is 4. -4, I made a mistake. -4 times 3 is -12. -12 times -5 is 60. Over 6. I was hoping to get something that's not a perfect square, and the numbers came out to be a perfect square. So it's equal to -2 plus or minus the square root of 64 over 6. Square root of 64 is 8. So it's going to be equal to -2 plus or minus 8 over 6. So therefore we see that x is equal to -2 plus 8 over 6, or x -2 minus 8 over 6. From here, we get 6 over 6, x equal to 1. And from here, x is equal to -10 over 6, which is equal to -5 over 3. Again, the important thing is the quadratic formula will work. So I'm going to transition now over into simplifying or factoring difference of cubes and sum of cubes. Okay. Expand. X plus 1 times x squared minus expand a plus b times a squared minus ab plus b squared. What is that equal to? Well, it's equal to a times a squared, a cubed. A times minus ab minus a squared b. A times b squared is plus ab squared. Let me double check. A times a squared, a cubed. A times minus a squared, ab minus a squared b. A times positive b squared is positive ab squared. Now we're going to multiply by this. B times a squared is a squared b. B times minus ab is minus ab squared. And b times positive b squared is b cubed. Combine like terms, we see this works out to be a cubed. This cancels this cancels that, plus b cubed. So this whole expression simplifies to just a cubed plus b cubed. This as a name, it's called the sum of cubes. Sum means to add. So the sum of cubes, a cube plus a cube, a cube plus b cube. And we discover that this is the same as this. Similarly, if I gave you a minus b times a squared plus ab plus b squared. If I gave you that, you're going to find that it's equal to a times a squared, a cubed. A times positive ab is plus a squared b. A times positive b squared is plus ab squared. And then negative b times a squared is negative a squared b. Negative b times a positive ab is negative ab squared. And negative b times positive b squared is negative b cubed. Simplify, we end up with a cubed. This cancels this cancels that, minus b cubed. So what did we notice? That this is the difference. Whenever you have subtraction, it's called the difference. Whenever you have addition, it's called sum. So this is the sum of cubes, you're adding cubes. This is the difference of cubes. So what we're saying to you is that the factorization of the difference of cubes is exactly this. The factorization of the sum of cubes is exactly that. So what I'm going to do is I'm going to write them together, and then we're going to try and use them. So there's a pattern. You're going to need to be able, if you're doing pure math, if you go on to advanced math, you're going to need to know what the factorization of a sum of cube, what the factorization of a difference of a cube is. And look at the pattern. If it's the sum of cube, you start with a plus b. If it's a difference of cube, you start with a minus b. Not rocket science. I'm just trying to show you the pattern, because in math, a lot of it has to do with seeing patterns and keeping that together. So what happens to the trinomial? So this is your binomial, same pattern as what you're working with. When you get over here, both of them have a squared, and both of them finish with positive b squared. Watch this. In order to get a cube, you must have b, positive b cubed. It must be positive b times positive b squared to get positive b cubed. In order to get negative b cubed, if this is negative, in order for you to get negative b cubed, then this has to be positive b squared, because negative b times positive b squared gives you negative b cubed. So these are consistent. This and this identical. This and this identical. And then if it's a plus here, in order for the middle terms to cancel out, this has to be a minus. If it's a minus here, in order for the middle terms to cancel out, this has to be positive. That's it. So now I'm going to go into how do we factorize sum of cubes, do some examples, and you can see what's going on. So, example. What is that equal to? X cubed plus 8. Isn't that equal to x cubed plus 2 cubed? 8 is 2 times 2 times 2. So now we have a sum of cubes. Sum of cubes. So, you know it's going to be a binomial and it's going to be a trinomial. A binomial times a trinomial. What is the pattern? Here's a template. It's going to be x plus 2. And over here is going to be the first thing squared. So it's x squared minus ab. So it's minus a is x, b is 2. So x times 2 gives you 2x. Then finally, plus b squared. This is your b. So it's going to be plus 4. I guarantee you, if you multiply this times that, then positive 2 times that, and combine like terms, you will get x cubed plus 8. Do you want me to do it? Okay. I'll do it so you can see for yourself. X times x squared, x cubed. X times negative 2x, negative 2x squared. X times 4, positive 4x. Multiply by positive 2. 2 times x squared is positive 2x squared. 2 times negative 2x, negative 4x. 2 times 4, positive 8. If you look at it, the middle terms cancel. The middle terms cancel. You're left with just x cubed plus 8. How beautiful is that? Let's try another one. Let's try y cubed minus 27. Y cubed minus 27. How do you factorize that? Well, see if you could write it as the difference of cubes. So you write it as y cubed minus 3 cubed, because that's what 27 is. 3 times 3 times 3 gives us 27. And now we see that we have a difference of cubes. So now we can use this template. Not the first one, but we need to use this one. So what do we have? We have our binomial and our trinomial. This is your A, this is your B. So you have y minus 3. And according to this, this squared is y squared. Plus, so it's plus 3 times y is 3y. And then again, plus 3 squared is 9. And I'm saying to you that this, when multiplied together, will give you y cubed minus 27. We're going to check to see if that works. And if it works, then we're going to try and solve one of these equations. Okay? Good. So let's check. Y times y squared, y cubed. Y times 3y plus 3y squared. Y times 9 plus 9y. So I'm finished multiplying by y. I'm going to multiply by negative 3. Negative 3 times y squared, negative 3y squared. Negative 3 times positive 3y, negative. And negative times a positive is negative 9y. Negative 3 times positive 9, negative 27. What do you notice? 3y squared cancels negative 3y squared. 9y cancels negative 9y. So we end up with y cubed minus 27. So it is exactly what I said it would be. Okay? So now I think we're ready. Oh, I need to do one more that's a little bit more involved. One that's a little bit more involved. Okay. Suppose we had 8x cubed plus 125. And you're asked to factorize that. Well, let's see if we could write it as the sum of cubes. Because if we could write it as the sum of cubes, then we're going to be in good shape. So, do you see that this is actually 2x? Let's check. 2x times 2x times 2x. 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. X times x times x. So 8x cubed is 2x to the third power. What is 125? It's 5 to the third power. So we have something cubed plus something cubed. Sum of cubes. Sum of cubes. So the factorization of this is going to be a binomial times a trinomial. So in this case, it's going to be, this time our A, our first part, is 2x, and our B is 5. So it's going to be 2x plus 5, and then here is going to be 2x times 2x, which gives us 4x squared. That's what happens when you square this. 2x times 2x gives me 4x squared. And then according to this, it says minus. And what is 2x times 5? Gives me 10x. And according to this, the last thing is plus b squared. B is 5. So plus 5 squared gives me plus 25. So if what I have done is correct, if I expand this, it should simplify. After all of that is finished, it should simplify to just 8x cubed plus 125. Let's check. X times 4x squared is 8x cubed. There it is. 2 times 4, 8. X times x squared, x cubed. 2x times negative 10x is supposed to be negative 20 x squared. See, 2 times negative 10, negative 20. X times x, x squared. 2x times 25 gives me 50x. 5 times, positive 5 times 4x squared gives me positive 20. Positive 5 times negative 10x gives me negative 15x. Positive 5 times positive 25 gives me positive 125. Do you notice that the middle terms are opposites, so they cancel. Positive and negative cancel. Positive and negative cancel. So we're left with plus, which is exactly what we had before. How cool is that? So now I would like us to solve a cubic equation with all the knowledge that we now have. This should be very interesting. This should be very, very interesting. So let's get ready to solve the first cubic equation. Now, looking at this equation, based on what we have been doing from the beginning until now, you should know that this equation has three solutions. Three solutions. How do I know? I look at the highest exponent, or I look at the degree of the equation. It's degree 3. It means that it has three solutions. If it was quadratic, that is degree 2, it would have 2 solutions. If it was quartic, meaning that degree 4, it would have 4 solutions. So whatever the exponent is, whatever the highest exponent is, that's the number of solutions. Okay? So we need to get 3 solutions. I'll give you an idea. Most students would write, add 8 to both sides, you get x cubed equal to 8. And then what cube gives you 8? They end up with x equals to 2. And that's it, they're stuck. But that's only one answer. But I am telling you that you need to get 3 answers. So that would not be enough. That's only partial credit. It's not complete. Because let's check it. 2 cubed is 8. 8 minus 8, 0. So that works. 2 works. But that's only one solution. So we need the other 2 solutions. So what do? Well, this is what you do. You try and factorize this, get it the way that we have discussed as the difference of cubes, and see what happens. So this is equal to x cubed minus 2 cubed. So it's equal to x minus 2 times. We have already practiced how to work difference of cubes and sum of cubes. So what does it say? It's going to be saying x squared, and then of course in this case it's plus 2x plus 4. Okay? Or what I should have done, it's equal to 0, so I should put equal to 0. It's an equation, so we're trying to solve. But let's check right here just to make sure we did correct. X times x, x squared. X times 2x plus 2x squared. X times 4 plus 4x. Negative 2 times x minus 2x. Negative 2 times positive 2x, negative 4x. Negative 2 times positive 4, negative 8. Simplify this, cancels this. So we end up with x. Sorry, x times, this is supposed to be x squared. There's a square. So this gives me x cubed. So we know that it works. We know that that's the correct factorization. Let me put this properly. It's too high. Yes, that's better. So, now that we have it as a product of a binomial times a trinomial, 2 terms times 3 terms. So for this part, put that equal to 0, And this part, put that equal to 0, and then solve the two parts. And that's how you get your answer. So the first part, we have x minus 2 equal to 0. So therefore, x is equal to 2. So that's the first solution. And then this is a quadratic equation. So this is going to give you the other two solutions. And for this, you will have to use the quadratic formula because this will never be able to factorize. So you'll have to use the quadratic formula to get the answer right there. So you end up with x squared plus 2x plus 4 equal to 0. And then therefore, x is equal to minus 2 plus or minus the square root of 2 squared minus 4 times a and c, all over 2 times a. Okay? And that is going to give you minus 2. And this is going to get you into an area of math that we're not studying right now. It's called imaginary numbers. It's going to get you into imaginary numbers, which is not going to be covered today. So we end up with minus 2 plus or minus the square root of 2 squared is 4, minus 16 gives me negative 12. All over 2. And I'm not going to go any further right there. This is negative 2 plus that divided by 2. That's one answer. Then negative 2 minus that divided by 2. That's the next answer. So 2 answers from here, 1 answer from there, 3 answers. Okay? So that's what I wanted to share with you in terms of how that works. Okay? So, where do we go from here? I'm going to start another concept with you, and we'll end up finishing that concept in the next session. And this is called completing the square, another way to solve quadratic equations. So you have factoring, you have the quadratic formula, and now I'm going to go into completing the square. So as a reminder, whenever you're given a sum of cubes or a difference of cubes, sum of cubes or a difference of cubes, you factorize, you get your binomial and your trinomial, and then you equate to 0, and then you solve the linear, solve the quadratic, get your 2 answers, get 1 answer. There are your 3 answers. Do you think we should do another one of these maybe? Yes? Another one just to confirm what we've just discussed? Yes, let's do another one. We did the minus, which is a difference. Let's do one which is a sum. So this time we'll go okay. Let's do 27x cubed plus 8. No, that's not use 8. Yeah, plus 8 equals 0. Okay. Okay. So this, I know we can rewrite as 3x cubed plus 2 cubed equal to 0. So here we have the sum of cubes. 3 times 3 times 3, 27. X times x times x, x cubed. 2 to the third is 8. So we know that this is correct. And the factorization becomes 3x plus 2 according to the template, it's going to be this square goes here, so that's 9x squared. And because this is a plus, we're going to have a minus. And it's going to be a times b. 3x times 2, 6x. And then this one is going to always be a plus. B squared is 4. So this is your binomial, this is your trinomial, equal to 0. And I promise you that if you were to multiply these two, you will get 27x cubed plus 8. Just for your benefit, we're going to check to show that I'm not playing games, I'm not tricking you, it's actually real. Let's check. Now, when you're working these problems, you don't have to check. But if you have time, it's good to check to make sure you did not make a mistake. Let's go. 3x times 3 times 9 is 27. X times x squared is x cubed. 3x times negative 6x is negative 18x squared. 3x times 4 is positive 12x. Let me quickly double check to make sure. 3 times 9, 27. X times x squared, x cubed. 3 times negative 6, negative 18. X times x, x squared. 3 times 4, 12x. Now we're going to multiply by 2. 2 times 9x squared, positive 18x squared. 2 times negative 6x, negative 12x. 2 times positive 4, positive 8. Combine like terms. 2x cubed, there's no other term with x cubed, so this is 27x cubed. This cancels this cancels this, plus 8. So we know that this is correct. Okay? And then from here, from this spot, we put this equal to 0, and we put this equal to 0. So this is a linear equation, you get one answer. This is a quadratic equation, you get your 2 answers. 1 plus 2 gives you 3 answers. As I said before, this will never be able to factorize. So you will need to use the quadratic formula. And of course, I told you that there is a third method that I'm going to teach you. It's called completing the square. And third method to solve quadratic equations. Now with factoring, that only works for some equations that can be factorized. So you would factorize and then use the zero product property. But then there are many quadratic equations that cannot be factorized. So therefore, factoring is very limited. And that's why I say to you that it's important that if you're going to do advanced math, that you must know the quadratic formula, because the quadratic formula can be used for any quadratic equation. It will solve all quadratic equations. Good news, completing the square will also solve any quadratic equation. There is no limitation. It will always work. Okay, good. So this is quadratic formula. From this, I'm getting 3x plus 2 equal to 0. So 3x equal to negative 2, x equal to negative 2 over 3. So you have one answer, and then over here, quadratic formula gives you the second answer. And I've already done the quadratic formula for you today, so we don't need to go over that now. I'm going to introduce you to the work we're going to do completing the square, and then next time we meet, I will follow through. Okay, this is the introduction, okay? And what is involved is having to do with perfect squares. For example, a plus b squared, that's a perfect square, is equal to a plus b times a plus b, is equal to a squared plus ab plus ab plus b squared. So we see that it's actually equal to a squared plus 2ab plus b squared. So whenever you expand a binomial, whenever you multiply a binomial by itself, you get the first term squared plus twice the product of the two binomial, the two terms, and then plus the square of the second part of your binomial. For example, x plus 3 squared is going to be equal to x plus 3 times x plus 3, which is equal to x squared plus 6x plus 9. Okay? So, how do I know that? X times x, x squared. X times 3, 3x. 3 times x, 3x. 3x plus 3x, 6x. 3 times 3 is 9. So there it is. Okay? And of course, if I go right here, I know it's going to be x squared, 2 times ab. ab is 3 times x is 3x. Double that gives me 6x. And then b squared, 3 times 3 is 9. So let's go another one. Y plus 5 squared is going to be y squared plus, multiply this by, multiply these two and double it. 5y times 2, 10y. And square this, 5 times 5 is 25. So that's the pattern. That's the pattern. Let's try another one. B plus 4. It's going to be b squared plus 4 times b, 4b. Double it, 8b. Plus 4 squared is 16. I'm doing these with you now because in our next session, when we do completing the square, we're going to be working with perfect squares, and that's what's going to be used to complete the square. I'm not going to go any further right there. I'm going to just leave it at this point, and then we'll pick up on Tuesday. So on behalf of the Brosis Foundation, I thank you for spending this time with us. And I hope that this was actually very interesting for you. It has opened your mind to the possibility of how to solve quadratic equations. We know that we can factorize some quadratic equations, but then there are others that cannot be factorized. So that's how the quadratic formula became very, very important. And then I also shared with you how to factorize sum of cubes as well as difference of cubes. And as a result of being able to factorize those, you're able to solve sum of cubes and difference of cubes. Well, for now, I say, looking forward to seeing you again. Enjoy the rest of your day. Thank you so much.